Okay, good morning, everyone. So today we'll hopefully finish the study guide for week 5. And then if time allows, siguro pwede na rin nating simulan yung week 6. However, for the problem set on Monday, we will start with the coverage will just be until the worksheet, the study guide for week number 5. So kahit simulan ko ngayon yung worksheet, yung study guide 6, ang covered pa rin ng problem set ay hanggang dito lamang sa coverage ng study guide for week number 5, all right? And also I already uploaded the answer keys to all the worksheets until worksheet number 5, but you still have to submit worksheet number 5. I think the deadline is Saturday if I'm not mistaken. So pero napagkasunduan naman natin na i-download nyo lang yung worksheets kapag ka nakapag-submit na kayo nung, yung answer key kapag nakapag-submit na kayo ng worksheets, right? So, but everything is now available from worksheet 1 to worksheet number 5. So once you have submitted worksheet number 5, pwede nyo na i-download yung answer key para hindi nyo na antayan yung feedback ng mga lab instructors nyo sa isa-submit nyo. Okay? So, all right. So, by the way, guys, nakikita niyo na ba yung word text on your screens? Nag-stack kasi siya sa monitor ko. Pero, how about you guys? Can you see it?
Oo, parang homepage ng iPad.
Naka-freeze din po.
Okay. Hold on. Tingnan ko kung... Let me try it again. Okay, I hope this is better now. All right. So I'm now flashing the part when we want to combine proof techniques. So last time I introduced you to proof by contradiction, wherein parang ginagawa natin, ina-assume natin na mali yung theorem. And from that assumption, we want to get to a contradiction, something that we know to be false, all right? And then so by the law of excluded middle, we can say na hindi pwedeng maging mali yung theorem. And so dapat i-accept natin na totoo yung theorem, right? So that is actually what we call the indirect proof. Kasi nga hindi natin tinatackle directly yung pagiging totoo ng statement to be proven. We are just showing the impossibility of it being false. Sa math naman, walang gray area. Sabi nga ng law of excluded middle, P or not P. So, ibig sabihin, at least alam natin na si P o kaya si not P ay hindi totoo or exactly isa sa kanila ay hindi totoo. Na-prove natin, napakita natin na hindi pwedeng maging totoo yung not P, so ina-accept natin si P. Alright? So that's the entire idea about the proof by contradiction. So, but again, remember that in proof by contradiction, we are assuming the negation of the conclusion. Walang method of proof na nag-assume ng Q, right? Because that is the statement that we want to get from the premises, right? So what I mean is, kapag ka nagpo-prove tayo ng P implying Q, alright? Kahit ano pang proof technique yan, direct method, proof by contraposition, or proof by contradiction, never nating ina-assume si Q. Alright, so I hope that's clear, because I don't want to see your proofs to start with assuming the conclusion. We never assume the conclusion whenever we try to do something, okay? Or when we are trying to prove something, okay? Now, it might be necessary to combine several proof techniques in a single proof, right? Especially may mga komplikadong theorem na kailangan nating mag-prove ng isang claim before we can attack the actual conclusion, or before we proceed to the actual conclusion. So sa loob ng isang proof, pwedeng more than one method yung kailangan nating gamitin, right? So let's look at one example of that. Like example 37. So in example 37, we want to prove that every rational number can be expressed as a product of two irrational numbers. So having no knowledge about, say, the characteristic of irrational numbers, other than it cannot be written as a ratio of two integers, the denominator being not equal to zero, medyo mahirap i-prove ng isang bigayan lamang yung statement na to. Kasi sinasabi ng statement, kapag ka meron tayong rational number, pwede ko siyang isulat na product ng dalawang irrational. So our attack could be, okay, ipakita ko na yung rational number na yon ay pwede kong isulat na product ng dalawang numbers, which I guess to be irrational, or which I think to be both irrational. Tapos kung makikita nyo, yung proof na gagawin natin ay gagamit ng dalawang factors, pero yung isa hindi natin sure kung irrational or hindi. Okay? So kaya kailangan natin ng parang two tiers dito sa proof neto. Okay? So let's look at how the Vertex did it. So, all right. So dapat daw lahat ng rational masulat natin as a product of two irrational numbers. So we started the proof by considering an arbitrary rational number R. Okay? And then, ang alam natin si R ay rational, so therefore si R pwedeng isulat as a ratio of two integers A and B such that B is not equal to 0. All right? Everything is fine. Now, we want to show that R can be written as a product of two irrational numbers, so magbigay tayo ng candidate factorization para kay R, consisting of two numbers which we think to be irrational. Okay? Tapos madali lang naman yan. May proof na tayo sa irrationality ni square root of 2. So alam natin si square root of 2 ay irrational. So gamitin ko siya para i-express si R. Okay? Now, kung gagamitin ko si square root of 2, si R, pwede kong i-factor as square root of 2 times R over square root of 2. Because we know that the square root of 2's will cancel each other out kasi ang cancellation law nag-hold sa kahit anong real number. Actually, sa kahit anong complex number. So, ibig sabihin, ito ay isang nice enough factorization for R. But we need to prove that indeed this is nice enough, or this will satisfy the requirement of the theorem, right? We should show that square root of 2 and R over square root of 2 are both irrational numbers. Okay? So sinimulan natin siya dito parang proof of existence. Nagpakita tayo ng isang example ng factorization ni R into two irrational numbers. Okay? Kaya lang may problema. Pag tinapos niyo yung proof niyo dito, meron akong may bubutas dun sa argument niyo. Okay, matatanggap ko na totoo si square root of 2 ay irrational, pero hindi ako sure kung si R over square root of 2 ay irrational. Walang theorem na nagsasabi na wala pa tayong encounter na theorem so far na nagsasabi na ang rational divided by irrational ay irrational. Okay? So that's why you need to show in another part of the proof that indeed R over square root of 2 is irrational. Okay? That's what the next part of the proof does. Okay. Sinabi niya lang, merong previous example na nagpakita na si square root of 2 ay irrational. So what remains to be shown is that R over square root of 2 is irrational. And ito na naman yung problema natin. Natutunan natin na mahirap mag-prove na irrational ang isang number directly. Kasi wala tayong specific form para sa mga irrationals other than knowing that hindi natin siya kayang isulat as a ratio of two integers, right? Kaya lang mahirap magpakita ng isang negative statement. So what we'll do here is to suppose for the sake of contradiction that R over square root of 2 is rational. Pagpalagay natin na rational si R over square root of 2, ipakita natin na may mabaviolate tayo na previously established fact. All right? So since we are assuming for the sake of contradiction that R over root 2 is rational, then that means it can be written as a ratio of two integers C and D where D is not equal to 0. All right? So usual ano naman siya, characterization ng pagiging rational. Tapos magdi-derive tayo ng contradiction. Okay? Now from here, what can we do? We can multiply both sides by what? Usual manipulation naman, we can cross multiply. So we get RD equals root 2 times C, and then divide both sides by C. Kakaproblema pala tayo rito, no? Kasi nag-divide ako by C. Hindi ako sure kung si C ay 0. Actually, mukhang may mali nga dun sa theorem eh. Hold on. Ngayon ko lang siya napansin. Every rational number can be written as a product of two irrational numbers. Napansin niyo ba yung butas dun sa proof? Anyone? Actually, ngayon ko lang siya napansin pala. Mali yung theorem. Sabi niya, every rational number can be expressed as a product of two irrational numbers. Can somebody tell me what's wrong with the theorem, with the supposed theorem? Hindi pala siya pwedeng tawagin theorem kasi may mali. Can anybody or napansin niyo ba yun? Anyone? While you're thinking about that, Victor is asking, alam ba natin na yung dalawang irrational numbers ay equal? Victor, do you mean square root of 2 and r over square root of 2? Actually, these two guys are not necessarily equal to each other depending on the value of r. So, hindi natin sure kung itong dalawa ay equal sa isa't isa, if that is what you are referring to. Let me see. Okay, Gad, may idea ka? Ano yung mali sa theorem?
Yung 0 po, sir.
Okay, kapag kasi r ay 0. Okay? So let's see. Yeah, I think you're correct, Gad. Yeah, that's what I'm thinking earlier. Si 0, kung susundan natin tong proof na ito, ay susulat ko square root of 2 times 0 over square root of 2, right? And this is a perfect factorization, and it will follow from the proof, right? So ito yung candidate natin para sa dalawang irrational numbers. Pero si square root of 2, yes, it's irrational, but 0 over root 2 is rational because 0 over root 2 is equal to 0. Alright? So ibig sabihin, hindi ito makakasatisfy or itong factorization na to ay hindi makapag-comply dun sa theorem because 0 in this factorization was written as a product of a rational and an irrational number. Okay? Now, may iba pa bang factorization sa 0? Actually, wala na, no? Kasi meron tayong theorem na kapag ka ang product ay equal kay 0, then either A is 0 or B is equal to 0. We know this from elementary algebra. Pag nag-multiply ka ng dalawang numbers, ang product ay 0, sure tayo na at least isa dun sa mga factors ay 0. So let us amend the theorem a little bit. Let's say that every non-zero rational number can be expressed as a product of two irrational numbers. Okay? Kasi nga nag-fail siya kapag kasi r ay 0. Okay? Now here, we can say that, so lagay natin r, which is non-zero. A rational number can be written as a ratio of a and b, where both a and b are not 0. Okay? Kasi nga si r ay hindi 0, so dapat si a na nasa numerator ay hindi rin mag-0. Alright? And then so that means I think so far everything is good. So here, okay, and then here we are, okay? So dito sa point na to, sinabi natin si R ay hindi 0. Si D ay hindi rin 0, right? So si R ay hindi 0, si D ay hindi equal kay 0, so the product cannot be equal to 0, right? So, hindi ito pwedeng maging equal kay 0. Okay? I mean, yung product na RD at saka yung root 2 times C ay hindi pwedeng maging equal kay 0. Right? So, dahil hindi siya equal kay 0, ibig sabihin si C ay hindi equal kay 0. Ito yung kailangang idagdag natin dun sa proof, right? So, I hope you see why C cannot be equal to 0. Kasi nga si R, dinagdagan natin ng assumption na hindi siya dapat 0. So, hindi siya 0. So, ibig sabihin, yung RD ay hindi 0. So, definitely si root 2 times C hindi rin equal kay 0. Kasi nga ito ay equal kay RD, which is non-zero. At dahil ito ay non-zero, so dapat si C hindi mag-0. Kasi si root 2 ay hindi 0. So, ito dapat hindi rin 0. To avoid the product being equal to 0. Okay? And now with this knowledge that C cannot be equal to 0, then we can divide both sides of this equation by C and get root 2 equals R times D over C. Okay? And then we'll go back. So nakakita tayo ngayon ng isang expression para kay root 2. Babalik ako, ano nga ba si R? Si R ay rational with expansion A over B na alam natin, right? Ito yung inassume natin sa taas na si R ay A over B. So, ibig sabihin, pwede ko itong palitan ng A over B. So, yun yung nangyari sa side na to. So, I get A over B times D over C equal kay AD over BC. But what can we say about AD and BC? In the numerator, A times D is a product of two integers. Ang product ng dalawang integers ay integers din. Yung B times C ay product ng dalawang integers. So si B times C ay integer din at hindi siya equal kay 0. Right? Kasi si B at saka si D ay parehas hindi equal kay 0. So therefore here, if we will accept the supposition that R over root 2 is rational, then we must accept that root 2 can be written as a ratio of two integers, the denominator of which cannot be equal to 0. Okay? So that means mali yung assumption natin dito for the sake of contradiction. So therefore, R over root 2 is irrational whenever R is not equal to 0. So therefore, indeed, yung factorization natin kanina para kay R ay comprised ng dalawang irrational numbers, which completes the proof of the statement. Okay, so and that ends the proof. I hope the proof is clear. Nakita niyo yung paggamit ng more than one method of proof. We have first part, we demonstrated a particular instance, and then second, nagprove tayo by contradiction. And this is usually, or you will encounter this probably in some of the theorems that will be proving in the future, or sa mga future major subjects nyo. Usual na gumagamit ng more than one proof technique in one particular statement. Sometimes though, pagka medyo importante yung result na ginagamit doon sa loob ng theorem, minsan hinihiwalay natin siya sa theorem of its own. So we could have phrased, so if you are writing this textbook, you could have phrased, or before itong illustration 37, you could have inserted one lemma. I don't know if you have heard of the term lemma before. So yung lemma parang siya yung result na ginagamit para ma-prove ang isang theorem. So isa siyang theorem, pero yung significance ng theorem na yon ay pang-prove siya ng isang theorem. So kung ito yung i-consider natin na theorem, pwedeng sabihin mong lemma ay yung R over square root of 2 is irrational for a non-zero rational number R. So kung meron kang non-zero rational number divided by an irrational, pwede nating ma-prove using the same argument as here na irrational yung quotient. So pwedeng inihiwalay ko siya sa separate theorem. Tapos, nung pagka-expand ko nito, okay, sabihin ko na, okay, by previous theorem, R over square root of 2 is irrational. So, minsan ganun. Tinatago natin minsan yung paggamit ng dalawang magkaibang proofs within a proof by just stating the other proof as a separate result. Okay? All right, so I think that's it for that example. Do you guys have any question? By the way, Esther sent in the chat pala her idea about ano yung problema ng theorem. Thank you, Esther. Okay, I think you're on the right track there. Thank you. Sorry, hindi ko siya napansin kagad. All right, so if there are no questions, then let's try to go on to another class of statements that we might encounter in the future, and let's see how to prove them. These are the biconditional statements because remember that biconditional statements are of the form P if and only if Q, right? I write IFF for if and only if, right? Pampaiksi nung isusulat. So P if and only if Q in symbols, this is denoted by the two propositions being connected by a double-headed arrow, right? Dahil mas madali siyang matandaan pag inisip niyo yung symbol niya na double-headed arrow because a biconditional statement is equivalent to a conjunction of two statements. Kaya mapapansin nyo, kaya pala double-headed arrow yung ginamit. P if and only if Q is equivalent to two statements or the conjunction of two statements, namely P implying Q. That takes care of the forward arrow. Kunin ko yung forward arrow. So P implying Q. And then to use the backward arrow, gagamitin ko yung conjunction. And P is implied by Q. Right? Or in other words, pwede ko itong isulat instead of a backward arrow, pwede ko siyang isulat na Q implying P. And this is essentially what a conditional statement, a biconditional statement is. It goes both ways, okay? So kalahati ng biconditional ay P implying Q. Tapos yung kalahati niya yung converse ng P implying Q. Kakaroon ka ng Q implying P. So you see how powerful or how encompassing an if and only if statement is, or a biconditional statement is. Because from P, we can get to Q, and from Q, we can go back to P. Kasi alam natin, kung totoo man si P implying Q, hindi necessarily totoo yung converse. Totoo yung contrapositive, pero yung converse ay hindi. In an if and only if statement, we are guaranteed that the statement and its converse are both true. Kaya sa pagpo-prove ng if and only if statement, medyo mabigat yung burden because we want to prove two things. Ang connective ay and. So dapat ito at saka ito ay parehas na totoo. So ibig sabihin, dalawang parte yung proof pag nakakita kayo ng if and only if. So pag if and only if, dalawa yung ipoprove nyo. You start with P, try to get to Q, and also start from Q, then go to P. Rarely, sa if and only if statements, pwede nyong ma-prove yung biconditional kaagad. Pwede rin namang isang diretso yung proof, pero dapat ginagamit natin yung biconditional kung rules of equivalence yung ginamit natin. Pag puro rules of equivalence yung ginamit nyo dun sa proof, then posible na ma-prove nyo siya sa isang bigayan lamang. Kasi yung mga rules of equivalence, if and only if yung ginagamit sa kanila. Pero once gumamit kayo ng rules of inference, okay, magiging one way na lang yung proof nyo. So kailangan talaga nating hatian yung proof sa dalawa. Okay? So let's see some examples here. I think isa lang pala yung example dito. But don't fret about it kasi na-cover na naman natin yung mga methods of proof. So isang example lang yung binigay kasi nakapag-prove na tayo ng maraming conditional statements. Yung added problem lang sa if and only if statements ay yung pag-prove ay yung hatiin siya sa dalawang cases. Pag nahati na natin siya sa dalawang cases, yung P implying Q at saka yung Q implying P, gagamitin na natin yung mga previously nating natutunang methods, be it a direct proof a proof by contraposition, or a proof by contradiction. Or pwedeng sa bawat isang part ng if and only if statement, gumamit tayo ng multiple methods of proof. Okay. So let's look at this example. Prove that if y is a real number, then there exists a number x such that 2x minus 1 over x minus 3 equals y, if and only if y is not equal to 2. So here we see the if and only if statement. So, or by the way, if and only if statements are sometimes called necessary and sufficient conditions. So kasi, bakit siya necessary and sufficient condition? Kasi yung P implying Q, ibig sabihin si P ay sufficient kay Q. Tapos si P ay necessary din para mangyari si Q. Alright? So ito yung sufficiency. P is sufficient to conclude Q. Kasi si P, pag totoo si P, alam natin nagfa-follow na kagad si Q. Ito naman, ang ibig sabihin nito, si P ay necessary para kay Q. Kapag ka nangyari si Q, automatically P happens. Right? So necessary na mag-follow si P. Kaya yung P, if and only if Q, sinasabi na rin natin na si P ay necessary and sufficient condition for Q to happen. And the necessary and sufficient conditions are actually the characterization for a definition. Kaya kung mapapansin nyo, yung mga definitions usually ginagamitan sila ng if and only if. Or kung hindi man siya gamitan ng if and only if, pag nilabel siya na definition, kahit if then lang yung nakalagay sa definition, alam natin at the back of our minds that it's a biconditional statement. Kasi nga, if and only if statements ay laging necessary and sufficient condition, and that's the precise meaning of what a definition is. Okay? Kaya sa mga definition natin sa set theory, makikita nyo, gumagamit ako ng if and only if statement para sa mga definitions. Or, sasabihin ko na sa inyo ngayon, na kapag ka nakalimutan kong gamitin yung if and only if, pero nilabel ko siya sa definition, biconditional yun, kahit hindi ko isulat yung if and only if. Alright? Now, going back to example 38. So, dalawang bagay yung gusto nating ipakita kasi nga ito ay if and only if. The first thing that we want to prove is we start with this guy and we want to arrive at y equals 2. Okay? So usually, yung proof sa biconditional statement, nilelabel natin kung anong direction yung gusto nating i-prove muna. So, but basically, I'll start with the common assumption that y is a real number. Nanggaling siya dito, right? And then after that, once I start attacking one part of the biconditional, usually nilalagay ko inside arrowheads, inside parentheses, yung direction na gusto kong i-prove. So in this particular case, I'll start with the forward direction. Ipo-prove ko muna yung P implying Q. All right? So that's why here I start by supposing that there exists a real number x such that the ratio is equal to y. Kasi ito yung P, siya yung assumption, and we want to prove y not equal to 2. Okay? And I think the vortex proceeded to a proof by contradiction for the first part. Okay? So here, by contradiction, or for the sake of contradiction, they assume y is equal to 2. Kasi nga gusto nating ipakita si y ay hindi equal kay 2. So kunwari, si y ay hindi not equal kay 2. So ibig sabihin si y ay equal kay 2. And since we are assuming that y is equal to 2, we can replace y here in the equation that we assumed earlier na palitan to ng 2. And we get this expression. All right. And then dahil alam natin na yung 2x minus 1 over x minus 3 ay isang valid na fraction, okay? Kasi inassume natin to yung equation, so dapat valid na fraction to. Ibig sabihin si x minus 3 ay hindi 0. So this is still valid, and we can multiply both sides by x minus 3, right? Doing so will give us 2x minus 1 equals 2x minus 6. And then we can subtract 2x from both sides, and we'll get -1 equals -6, which is a contradiction. Okay? So kung tatanggapin natin na si y ay equal kay 2, so dapat tanggapin din natin na si negative 1 ay equal kay negative 6. But we cannot do that because we all know, since we learned negative numbers, na yung negative 1 ay hindi equal kay negative 6. At least sa realm ng real numbers. Okay? There could be some mathematical universe na negative 1 ay equal kay negative 6. You learn something about that when you go probably to Math 111 or Math 103. Pero for now, alam natin na si negative 1 ay hindi equal kay negative 6 sa realm ng real number system. So, ibig sabihin, hindi pwedeng si y ay mag-equal kay 2. So we need to accept that y is not equal to 2. All right? And that ends the first part. We have proven that P implies Q. Now, we need to prove the converse because, again, the statement is a biconditional one. So, kailangan kong i-prove yung backward arrow. Sa backward arrow, kailangan kong i-assume naman si Q, ipakita ko si P. All right? So, here, conversely, in-assume ko na si Y ay hindi equal kay 2. Then, ano yung P natin? Ano yung first statement dun sa biconditional? There will exist an x such that 2x minus 1 over x minus 3 ay equal kay y. So, or probably I should put that here. Insert ko lang. We want to show that P is true. And what is P? There exists an x in R such that 2x minus 1 over x minus 3 is equal to y for any given y. So, sabi dito, kailangan nating maghanap ng real number x such that this equation will be true for a preordained y or for a preset y. Okay? Basta alam natin si y ay hindi equal kay 2. Right? So, pwede kayo mag-preliminary analysis, solve for x from this statement kasi nga we need to find x. So, look for x here. Solve this equation. And you will find that x is equal to 1 minus 3y over 2 minus y. Okay? And then here is where the assumption that y is not equal to negative 2 will kick in. Bakit kailangan natin na si y ay hindi equal kay 2? Kasi nagkaroon tayo sa denominator ng 2 minus y. And for x to be well-defined, or this fraction to be well-defined, dapat hindi mag-zero yung denominator. But now we are sure that the denominator is not 0 because part of our assumptions is that y is not equal to 2. So this is a valid fraction. Okay? And so dahil valid si x na real number, then kailangan ko lang ipakita that this choice for x will make this guy equal to y. And again, if you want to prove an equation, start lagi kayo sa isang side lamang. Start ako sa left side, hoping na papakita ko na to ay equal kay y. And then again, we chose x to be equal to this guy, so we can just replace all x's by that fraction there. And then simplify, bunch of algebra steps will arrive eventually at y. And so we have found, or we have supplied an x, a valid real number, for any y not equal to negative 2, such that this is equal to y. All right? And that ends the proof. Pero kita nyo, medyo madaya yung biconditional. Kasi dalawa yung kailangan nyo talagang i-prove. So kaya pag nakakita kayo sa problem set ng biconditional statement, medyo dinaya ko kayo doon. Kasi dalawang proofs yung kailangan nyo gawin. So pwede pala na kung itetest ko kayo sa proof by contraposition, sa halimbawa proof by contradiction, isa na lamang yung problem. Na yung gawin ko siyang biconditional, na yung isang direction can be proven using contradiction, tapos yung isa i-prove by contraposition. Okay, so yeah. Okay, so and I think that ends worksheet number, the study guide for week number 5. Okay, any questions, guys? Oh, by the way, ngayon, marami na kayong alam na methods of proof, right? I think you know all the basics except one, which is the proof by mathematical induction. Pero pagka sa exam, sa problem set, or sa kahit na anong ginagawa nyo, pag kailangan nyo i-prove yung isang bagay, hindi usually sinasabi kung ano yung method of proof na gagamitin. So, ibig sabihin, kailangan nyo i-determine on your own kung ano kaya yung pinakamagandang proof technique na gamitin. And unfortunately, I cannot give you a hard and fast rule para magsasabi na pag ganito yung itsura ng theorem o ng statement to be proven, ganito yung method na kailangan yung gamitin. Usually, it really depends on, number one, the statement itself, and number two, on what are the previous results that you can use. Kasi baka naman nagtatry kang mag-proof by direct approach, pero dun sa proof ng direct method, kailangan mo ng isang result na hindi mo pa na-prove. So, kaya kailangan yung kapain kung ano talaga yung most appropriate method of proof. Now, as you go along further into your careers, mas naging madali na spot yung ano yung method of proof na kailangan gamitin. Usually instinct yan or gut feel. So kaya lang you cannot develop an instinct or a gut feel if hindi kayo sanay or hindi kayo nagpa-practice mag-prove ng maraming bagay. I guess in this case, experience is the best teacher. Because experience will help us develop the instinct para magsabi kung ano yung kailangan kong gamitin para i-prove yung isang theorem. Okay? So, yes, Gad, you have a question?
Sir, meron po ba kayong any site or any suggested materials po for more practices po?
Okay, good question, Gad. I think at the start of the problem you can go back to the study guides. Hold on. Scroll up ko lang. Layo pala. Okay. Merong mga supplementary materials dito. Yeah, you can visit this website. So, halimbawa sa topic 1, Contrapositive Proof, there are a lot of links here. If you are more of a bookish type, meron diyang mga websites or mga online textbooks that you can access using these links. Or if you are more of a visual person, siguro mas okay yung mga videos. So pwede niyo itong tingnan. So I think sa lahat ng study guides, merong ganitong section. So these are nice materials, or these are the materials that were used by previous lecturers to supplement the discussion. So pwedeng ito yung mga pag-practicean niyo. All right. So I hope that answers your question, Gad. Ito pa pala, kahit sinabi ko na usually walang sinasabi ng method of proof na gagamitin. So free kayo na pumili kung anong method yung gagamitin nyo. Pero halimbawa, merong isang particular item sa problem set na sinabi ko, i-prove nyo to using contradiction. Then you should oblige to use proof by contradiction. So pag sinabi ako na method of proof na gamitin sa problem set or sa worksheets, dapat yung method of proof na yon yung gagamitin nyo. Kasi otherwise, I cannot give you points for it. Kasi nga, isang statement can be proven in many ways. Hindi unique yung proof. Kahit nga direct proof, posibleng iba-iba pa rin tayo ng direct proof. Or kung proof by contradiction, posibleng iba-iba tayo ng makuhang contradiction. Right? So if I want to test you with a particular proof technique, and I know that this theorem can be proven in many ways, pwede kong i-impose na gumamit kayo ng proof by contraposition para sa statement na to. Okay? So, kailangan yung sundin yon. Pero kung wala akong sinabi na method, and I just say, prove the following, then bahala na kayong mag-isip kung anong proof technique ang gagamitin nyo. Okay? Use your creativity, use your instincts to decide paano ipoprove yung statement na yon. All right? Any other questions? Wala ng questions? Now, we still have 9 minutes. I'm thinking, start ba natin yung study guide 6? Or wag na lang? Let me see. Siguro wag na lang muna. Okay, so para hindi na rin kayo burden or wag niyo na muna siyang isipin for the problem set. Okay, yeah, no worries, Mary. Wag na nating simulan muna. So, all right. So, any other questions, concerns? May mga pahabol ba na request for the problem set? What is the deadline for, what time is the deadline for the problem set? Did I say it's 5 p.m.? Parang sinabi ko sa kabilang section, sige, hanggang 11:59 p.m. na.
11:59 po yung sabi niyo sa amin last time. So.
All right before midnight. Okay, that's fine. Kasi kung ang nasabi ko ay kung ang nasabi ko ay 5 p.m. gagawin ko namang 11:59 p.m. to give you more time. Si Esther, my question, handwritten po ba with picture yung problem set? Yes, I would like as much as possible the problem sets to be handwritten. Esther, do you mean handwritten yung isa-submit nyo o handwritten yung handwritten yung questionnaire para sa problem set? Yung sagot. I prefer that it be handwritten. I think it's much easier for you, or medyo nahirapan ba kayo sa handwritten? Kasi ang yeah, pwedeng electronic pa rin na handwritten. So if you have a tablet with you, pwede niyo siyang isulat direct to your gadget, okay? So or yung iba nga may mga apps na ngayon sa phone na nakakapagsulat using your fingers. So usually touch screens na naman yung mga phones nyo malamang. So pwede niyo siyang gamitin. Yeah, okay lang din siya. The whole point of asking you to write your answers ay para hindi kayo nagka-copy paste lang. Yun lang yung gusto namin i-avoid. Ma-ensure na at least nagsulat kayo. Kasi pag nagsusulat kayo, siguradong may konting information, may at least kaunting information. So in our parlance, there exists an information na mariretain sa inyo pagka sinusulat nyo ang isang bagay. So kahit nakita nyo yung eksaktong proof sa isang site sa internet, tapos sinulat nyo siya by hand, kinopya nyo lang siya without thinking, I think there are still some things that will be retained to you consciously or unconsciously. Alright? Kesa naman, ika-copy-paste nyo lang siya, tapos yun na yung submission nyo. Wala talagang mariretain sa inyo doon kahit konti. Pero yun yung worst case. But I encourage you, even if you visited some sites, halimbawa, na-stuck kayo, tapos problem set naman to, hindi ko naman kayo pinagbabawalan na mag-search ng internet because there's no way I can enforce that order. Okay? So, kaya inaasong ko na lang sa paggawa ng problem sets na posible mag-search kayo sa internet. So, kung na-stuck kayo, okay, it's fine. You can consult the internet. You can even consult with your other classmates basta may consent nila. So, basta siguraduhin nyo na pag sinulat nyo siya on paper or on your tablets, naintindihan nyo siya. Okay? So may mga proofs kayo makikita sa internet, kaya lang siguro kulang-kulang yung detalye ng proofs or kahit sa textbooks. Halos lahat naman ng ipoprove natin ay na-prove na before. Kasi kung nagpa-prove ako sa inyo ng hindi pa na-prove before, pang thesis na yon, pang SP na yon, alright? So dahil lahat naman ng results na ipoprove natin ay existing na, so chances are it is somewhere. It is in a book or it is in a website, right? So posibleng talagang ma-search niyo siya. Pero usually makikita niyo mga proofs, may mga detalye na hindi sila sinasama. Yung mga books sasabihin, it is clear that this statement is true. Pero pagka sa exam natin or sa problem set natin, hahanapin ko bakit siya totoo. Kung hindi clear sa akin, kailangan yung i-prove. So kahit makita niyo yung proof sa internet, kailangan yung i-supply yung mga details. Okay? Or kung nag-study group kayo, tapos na-stuck ka talaga, humingi ka ng suggestion dun sa classmate mo. Sinabi ni classmate, ganito yung steps. Now, okay lang naman, nagamitin mo yung suggestion niya, but make sure that once you write it on paper, alam niyo siya. Okay? Or naintindihan niyo kung ano yung gustong sabihin ng statement na sinulat niyo. So I do not discourage you from talking with each other about the problem set. Ang tanging request ko lang, lalagay ko rin to sa instruction ng problem set, that when you consulted an online resource, a printed resource, or whatever, paki-indicate yung reference. Lagay nyo lang reference. Or, sir, I consulted this website. Or, I found this result in this book na ginamit ko as inspiration for my answer. So, lagay nyo yun dun sa item na yun. Or kung nag-study group kayo for a particular problem, sabihin nyo doon, sir, I worked with classmate A and classmate B for this problem. Para alam ko lang na, okay, nag-work kayo. Wala naman deduction. So I will actually appreciate it more if you will say kung saan nyo nakuha yung inspiration. Pero okay lang din naman, kung hindi kayo kumuha ng inspiration, naisip nyo yung proof on your own, then that's also perfectly fine. Okay? But there's no shame in admitting that you consulted somebody or something in order to come up with a proof. And I think it's nice to keep it as a habit kasi sa academia dapat ganito tayo. Lahat ng mga reference natin binibigyan natin ng due credits. Kung nga sa memes naglalagay kayo ng CTTO, di ba? Or sa Facebook post nyo nag-CTTO kayo. So what more sa isang formal submission like a problem set or an exam? So bigyan natin ng credit kung kanino man due yung credit na yon. Be it in a textbook or be it from your classmate. And anyway, there's no deductions for it. So why not declare it? All right. So any other questions? Sorry, naubos ko rin yung 10 minutes kakadada, no? Hindi nga tayo nag-start ng bago, pero yeah. May question si Elgin. Kapag ka need po ng multiple initial proofs, tapos for example, nasa worktext po, need po ba i-reiterate yung proof? Okay, so I think, Elgin, you're saying here na kapag ka meron kang result na kailangan dun sa proof mo, pero na-prove na natin siya sa worktext, kailangan pa ba ng proof? Hindi na. Okay. So kung halimbawa, tama ka, Elgin, halimbawa ginamit nyo sa proof na kapag ka si x ay even, then x squared is even. Kung na-prove na to sa worktext, hindi nyo na kailangang hindi nyo na kailangang i-prove pa. Pero kung hindi pa natin siya na-encounter sa klase at hindi siya isang elementary result na possibly natutunan nyo sa math, ano ba prereq ng 101? Nakalimutan ko na. Math 36 nga ba? Or 37? Tandaan nyo ba, guys? Basta hindi nyo pa siya na-prove sa prereq. So, okay, for some, it's math 27 and AMAT 19. And then, math 28, layo pala ng math 101, no? How about for the math majors? Sorry, hindi na ako familiar sa curriculum kasi yung bago niyong curriculum ay na-approve 2018, naka-study leave na ako nun. Yes, Gad, you're saying something?
Parang math 20 po ata, sir.
Math 20 at saka, ang alam ko may isang calculus either
36
or 37. Okay, so basta hindi pa siya na-prove sa prereq or hindi siya common knowledge, kailangan niyo siyang i-prove. Okay? Pero kung na-prove na siya sa work text, hindi niyo na siya kailangan i-prove. Sabihin niyo na lang yung result. Sabihin niyo na lang, since we know that if x squared is even, then x is necessarily even, then pwedeng hindi niyo na siya isulat. Oh, thank you, Victor. Math 37 daw pala. Inisip ko nga, baka pwede nang ibaba sa Math 36 Pero pag-isipan namin yan sa Math Division probably next semester. And then there's another question from Mary Mitzi. Magpapasa pa rin po ba ng worksheet 5 kahit may answer key na po? Yes, Mary. Kailangan nyo mag-submit ng worksheet number 5. I think the deadline is on Saturday. Kailangan nyo pa rin mag-submit kahit may answer key na. Kasi ang usapan natin, i-download nyo lang si answer key kapag ka nakapagpasa na kayo. Alright? So magpasa pa rin ng worksheet 5. Medyo sinipag lang ako kagabi. Mag-browse ng Google Drive namin ng mga lab instructors nyo. Meron na palang answer key worksheet 5. Kaya in-upload ko na rin siya. So, pero i-access nyo lang naman siya kung nakapagpasa na kayo. So, submission still is required for worksheet number 5. After you submitted, you can access the answer key. Ang canceled ay yung worksheet 6. Okay? Hindi na muna i-deadline yung worksheet number 6. But probably, I will assign worksheet number 6 pala later. So, hindi pala siya cancellation. Ipopostpone lang natin yung submission. Siguro after nating ma-discuss next week yung proof by mathematical induction. Okay. All right. And then speaking of the proof by mathematical induction, medyo binago ko to. Ito dapat ay nasa dulo pa or nasa after pa ng set theory. Medyo nasa padulo pa dapat siya ng Math 101. Ganun yung ginawa in the previous semesters and also in the textbook. Nasa dulo pa yung proof by mathematical induction. But I decided that PMI is a method of proof. Hindi nyo kailangan malaman yung pinaka-technical basis niya. So kaya I decided na isama na siya sa methods of proof. Kasi kung medyo matagalan tayo sa pagdidiscuss ng Math 101, there is a chance na hindi natin siya ma-discuss or kakaunting oras yung ma-devote natin sa kanya sa dulo para i-discuss ang PMI. And yet, PMI is a very powerful method of proof. So kaya I decided to move it earlier. Tapos, ikakwento ko na lang sa inyo bakit siya nagme-make sense or bakit siya naging valid na method of proof without all of those details that will be introduced in set theory. So sabihin ko na lang intuitively bakit nag-work yung proof by mathematical induction. Ano yung basis niya? Tapos i-reinforce na lang natin yung notion na yon with the technical details when we have the necessary topics from set theory. Okay? Pero yun yung maging schedule natin. At dahil ni-rephrase ko yung parts ng work text, so merong hiwalay na module para sa PMI. I think it's already in Canvas, so make sure you visit Canvas and you will see this file, the module on PMI. Okay, okay, there you go. Meron tatlong examples dyan and then some exercises here. Yeah. Make sure to download this. Though yung examples dito ay the same examples na nandun sa work text, pero kailangan ko siyang i-rephrase para iba kasi yung language na ginamit dun sa work text. Ginamit yung language ng set theory o yung technical language of PMI. Pero dito, tinanggal ko yung technical language na kailangan ng concepts ng set theory na madidiscuss pa natin later. So para lang maipasok siya ng ganito kaaga, kailangan kong i-rephrase yung mga examples. So kailangan kong gumawa ng bagong module for it. So kindly download it in preparation for next week. And ito yung gagamitin natin sa discussions natin on Tuesday. Okay? Other concerns? Questions? Last na pala. Tandaan nyo ba yung grading system natin? Naka-specify ba kung ilang percent bawat problem set? Kasi alam pa sa Canvas, ginawa akong 19% for problem set. Yun din yung idea namin nun. I was thinking kung pwedeng lakihan ko yung percent ng problem set 1 kasi halos kalahati ng SEM yung nag-google natin sa kanya. Pero I'm still debating that. I'm debating with myself. Pero I'm still thinking about it. Kasi pwede pala na hindi ko siya lakihan yung percentage kahit nakalahati ng SEM yung ginugol natin sa kanya. Kasi yung mga problem sets natin sa set theory, sa second part ng course, ay mangangailangan ng mga methods of proof or methods of logic na na-discuss natin sa Unit 1. So integrated itong first part, yung logic, dun sa set theory. So kaya hindi nyo pwedeng kalimutan yung mga na-discuss natin dito sa logic part, especially the methods of proof. Kasi sila yung gagamitin natin paulit-ulit sa set theory at actually siya rin yung gagamitin nyo sa mga major subjects nyo. So kaya pala, okay, yan. Final na. Hindi ko na babaguhin yung final grade. So tama si Mary, 76% ng final grade ay problem sets. Tapos may 4 na problem sets. So kaya tigda 19% sila. Bakit 19%? It's not a joke. Kasi ang idea namin initially ay merong 4 na problem sets saka may isang final exam or final project. So equal weight sila sa tigda 20% sila. Kaya lang as we discuss with your lab instructors, naisipan nila na magbigay ng class participation na 5%. So, kaya naging 95 na lang yung total nung 5. So 95 divided by 5, 19%. So tigda 19% yung bawat isang problem set saka yung final exam. So just in case you're thinking, bakit ang weird? 76%. So yun yung backstory nung 19% per problem set. Okay, so sorry kahit hindi tayo nag-start, naubos ko pa rin yung oras kakadada. Pero any other concerns? Alright, kung wala na, so yung ilan na nag-recite today, kindly verbally, kindly put your names on the comment section. I'll put yours, Gad. Tanda ko nag-recite ka. So for those who recited, paki-comment na lang. Sorry, kukunti yung recitation ngayon kasi kukunti rin yung examples. Yeah. So that's it for now. So thank you guys for waking up early again today. And then enjoy the rest of the day. Enjoy the weekend kasi sa Monday, meron kayong problem set. All right? So bye everyone.
Bye, sir. Thank you po.